Remember from our last lesson, we solved these systems of equations by graphing, and this time we're going to solve them algebraically. So I'm going to use substitution method. So I'm looking at this set of systems right here, and the process that I'm going to do is when I solve by substitution is I take one of the variables and I solve it. So this second equation is solved for y already, and I take the 2x minus 3 and I plug it back in for the y. So let's just practice an example like that down here below. So I'm going to rewrite that problem. X plus 4y is equal to 6, and the second equation is y is equal to 2x minus 3. So solve by substitution says I solve one of my equations for a variable and I substitute that right back in. So since my second equation is already solved for y, then I say x plus 4 times what I solved, what y was already 2x minus 3, and that's equal to 6. Now I have an equation that's all in x's, and I can just solve for x. So x plus 4 times 2 is 8x minus 12 equals 6. Combining my like terms, 9x minus 12 is equal to 6. Add 12 to both sides. 9x is equal to 18. Divide by 9, and I find out that x is equal to 2. Once I solve for x, I have to remember that a solution to a systems of equation is actually an ordered pair. So I have an x value of 2, but I need to find my y value. So I'm going to take this 2 that's x, and I'm going to substitute that in to one of my other equations. It doesn't matter which one I choose. I'm going to choose the y is equal to 2x minus 3. So I get 2 times 2 minus 3, and I find out that y is actually equal to 1. So the solution to my set of systems is the ordered pair 2, 1. All right, so let's practice the second example. The second example is 6x plus 3y equals 12. And the next equation in that system is y is equal to negative 2x plus 4. So I'm going to rewrite that down here a little bit further down, and I get 6x plus 3y is equal to 12. And the second equation, again, is y equals negative 2x plus 4. So once again, when I solve by substitution, I need one of my equations to be solved for a variable, y equals. In this case, it's already solved. And I'm going to take that and I'm going to plug it right back in for the y value. So let's rewrite this as 6x plus 3 times negative 2x plus 4, because I'm substituting back in, is equal to 12. And now once again I have all x's, so I can just simplify this equation. 6x minus 6x plus 12 equals 12. Well, what happens to my x's? They're going to cancel out, and I'm left with 12 equals 12. It's at this point that we need to remember from our last discussion that a solution to a systems of equation can have 3 possible solutions. The first solution can be the ordered pair. We can have one solution, right, with an ordered pair. Another option for a solution to systems is for the solution to be infinite solutions. That was where one line lied on another line. And in this case, since I found out that 12 is equal to 12, I need to think to myself, well, is that a true statement? Yes, it is true. Because this is a true statement, the answer is infinite solutions. Okay, so we've seen now that we can have one solution, which is an ordered pair, We can have infinite solutions where my statement is true, and we will see that we can also have no solution, which is when my statement is false. So let's look at one more example of solve by substitution. The previous two examples that we've looked at, let me scroll back up here to the very top. The previous two problems that we looked at in this first set of systems, one of the equations was already solved for y. In the second set of systems, one of my equations was once again already solved for y, but that is not always the case. With it may come a time when we have to actually solve an equation for x or y. And let's look at an example that is similar to that. So if I start out with the equation 4x plus 3y is equal to 9, and I have another equation in my system of 3x plus 4y is equal to 12. Now I look at these two equations and neither one of them is solved for y, so I have to do that. And it doesn't really matter whether I choose to solve for x's or for y's, so I'm just going to pick one. I'm going to choose to solve the red equation, 4x plus 3y equals 9. Let's call this equation 1. I'm going to solve equation 1 for y. So I try to get y by itself. 3y is equal to 9 minus 4x. Then when I divide everything in here by 3, I get y is equal to 3 minus 4/3 x. So what I have done is I have solved one of my equations for y and found that it's 3 minus 4/3 x. And I'm going to take that value and I'm going to plug it into my second equation for y. So let's do that off to the side. We have 3x plus 4 times my substitution part, 3 minus 4/3 x, equals 12. So I just need to simplify this a lot further. We have 3x plus 4 times 3 is 12, minus 4 times 4 is 16 over 3, x equals 12. Here I have to subtract a fraction from a whole number, and I can do that on my calculator. I can do it on the side, but I find out that 12 minus 7/3 x equals 12, where I subtracted my x's. So now I subtract 12 from the left and then from the right, and I find out that negative 7/3 x is equal to 0. So x is equal to 0. So that's the first number in my ordered pair, and I'm going to take this value of x equals 0 and I'm going to plug it back into my original first equation. Always substitute back into an original equation, not one that you've just modified. So let's substitute it back in there, and we'll write this as 4x, or 4 times 0, plus 3y is equal to 9. So 3y is equal to 9. So y is equal to 3. So now I found that my ordered pair, the answer or the solution to my systems of equations, is actually 0, 3. And those are 3 examples of how you solve a systems of equations by substitutions.